Imagine you're flying in a spaceship, close to the speed of light. As you speed up, time around you slows down. Space itself begins to bend and twist. This might sound like science fiction if you've never came across Einstein's mind-bending theory of relativity. Buckle up, because today, we're taking a journey into the mysteries of space, time, and gravity like never before. So, what is relativity? Simply put, it's the idea that space and time are not fixed. They can stretch, shrink, and even slow down, depending on how fast you're moving or how much gravity there is. It all started when Einstein had a crazy thought. What if light always travels at the same speed, no matter how fast you're moving? This idea led him to two incredible theories: special relativity and general relativity. Let's start with special relativity. Imagine you're aboard a spaceship traveling close to the speed of light. According to Einstein, as you go faster, time starts to slow down for you compared to someone back on Earth. This is called time dilation. So, while only a few hours pass for you on the ship, years could be passing for people back home. It's almost like time travel. In fact, if you flew fast enough, you could return to Earth hundreds of years in the future, while barely aging at all. This sci-fi scenario is a real possibility thanks to Einstein's equations. But Einstein didn't stop there. He realized that gravity isn't just some invisible force pulling things together. It's actually the warping of space and time itself. This is general relativity. Imagine space-time as a giant trampoline, and planets and stars as heavy balls sitting on it. The bigger the object, the more it bends the trampoline, and the stronger the gravity. This means that gravity can bend light, stretch space, and even slow down time. Near a black hole, where gravity is insanely strong, time almost stops entirely. In fact, if you could somehow orbit a black hole without getting torn apart, you'd experience time much slower than anyone far away. Chapter 4. The Twin Paradox. Now let's bring it all together with the twin paradox. Picture this. You and your twin brother or sister. You hop into a spaceship and blast off at nearly the speed of light, while your twin stays on Earth. You fly around the galaxy experiencing time dilation. After a few years you return, and guess what? Your twin is now much older than you. You've barely aged, like you've skipped through time. This paradox is a direct consequence of special relativity, and it's one of the weirdest and coolest ideas in physics. Traveling near light speed could literally take you to the future. Chapter 5. Sci-fi meets reality, wormholes and time travel. Now let's go full sci-fi, wormholes. According to general relativity, space-time can bend so much that it might form shortcuts between distant parts of the universe. These are called wormholes, and if they exist, they could allow for faster-than-light travel or even time travel. Scientists haven't found any real wormholes yet, but the math works. And if we could stabilize one, it would let you travel across vast distances in an instant. Like something straight out of Interstellar or Star Trek. You could even jump to another point in time. Chapter 6. Gravitational waves, ripples in space-time. And then there are gravitational waves, ripples in space-time itself. When massive objects like black holes collide, they send shock waves through the fabric of the universe. We detected these waves for the first time in 2015, and it confirmed Einstein's theory in a spectacular way. It's like the universe is ringing like a bell, and we can finally hear it. These waves carry information about the most violent events in the cosmos, from colliding black holes to exploding stars. It's a real-life cosmic ripple effect. Chapter 7. The Future of Relativity. Can we harness it? Einstein's theory has unlocked the deepest mysteries of the cosmos, but we've only scratched the surface. Could we one day manipulate space-time, build spacecraft that travel through wormholes, or use gravitational waves to communicate across the universe? While we're still far from harnessing these forces, the science fiction of today could become the reality of tomorrow. Einstein's theory has opened the door to a future where space and time are no longer the limits they once seemed. So, what do you think? Could we one day travel through time and space, bending the universe to our will? Let me know in the comments below. And if your mind's been blown, make sure to hit that like button, share, and subscribe for more epic journeys through the cosmos. Until next time, keep exploring the wonders of relativity.